Can you see my screen? Okay, any doubts? Okay, so we were discussing about roots of a polynomial, right? So first of all, you already know polynomials are equations that contains variables and constants, right? Usually you denote polynomial using px. So px is a polynomial. So it is a function of x. So it can be linear in the form ax plus b. It can be quadratic, ax square plus bx plus c. It can be cubic and so on. Right. So when the degree is 1, it is known as linear. Degree is 2, it is known as quadratic. Degree is 3, it is known as cubic. If the degree is 1, it will have only one root or 0. Root or 0 mean? Not a factor. It means the value for which this becomes 0. Right. So if I say if alpha is a root of this, which means p of alpha is 0. Okay. And x minus alpha is a factor of p of x. Okay. Is this clear?
Yes.
Or say if you take x minus beta, right? So I'm asking you that tell me the remainder when when this polynomial p of x is divided by x minus beta. If a polynomial is divided by another polynomial, right? So what will be the result, or what will be the remainder?
P of beta.
Yeah, very good. So it will be p of beta, right? So if this is 0, which means if this becomes 0, this means x minus beta was a factor because the remainder is 0. Right, so this is what is the remainder and the factor theorem. Okay. Then we discussed about the I am recording the lecture today. I'll share it with you if hopefully everything should work fine today. Okay. If you are recording, let it be, but I'll share it. Okay, then we saw the graphical representation, right? What is how can we interpret the roots graphically? So you know that this represents a straight line, right? So this is a straight line. Okay. So this represents the x-axis, this represents the y-axis. So we are plotting y. So this is also known as y. Okay. So we are plotting this value. So y is p of x. So which means y is a function of x. Right, you already know velocity, so you have drawn velocity time graph. Velocity is a function of time, right? So whatever is the dependent variable, dependent means it depends on something. Y depends on x, right? So dependent variable, you represent it in the y-axis. Independent variable, which you are changing, right? So x is something you are changing and the value of y depends on x. So x is an independent variable because you have control over it. Okay.
So sir, which of them to keep independent or dependent is in our hands, right?
Yeah. Right. Usually the notation is such that y is the dependent variable.
Yeah.
Right. You can also write x equals to 3y plus 8. Right. So then x would be the dependent variable, y would be the independent variable. But this is not the convention. The convention is that y is always the dependent variable, x is the independent variable. Okay.
Yes.
So here what you do is you plot the independent. You already know how to draw, linear equation in graph, right? How to plot a linear equation. Just plot 2 points in the graph and then join using a line. So you'll get the entire equation. So there will be a point wherein it will intersect the x-axis. So when it intersects the x-axis, so this is the point, right? Which means at this point x has some value, right? So this is the number line for x. X has some value, but y is not moving. So this is the number line for y. So y is stuck at 0 at this point, right? If you look here or here, y has some value, but at this point y is exactly 0. So this means the value of x at this point is a root.
Yes.
Okay, is this clear? So this is the graphical interpretation. So that was for linear equation. For quadratic, you know, it will be a U-shaped curve. Why?
Because for every point it has two values.
Yeah. So for for any value of, or for two values of x, y has the same value. Okay, so if you look at this value of x, right, so you can consider this. So this is around, what is the value? It is 4, right?
Yes.
So it is 0 when x is 4, and at the same time it is 0 when x is minus 4. Right, so for two different values of x, it can have the same values. Similarly, at this point also you can see x has different values, but y has the same value. Right, and it is usually the mirror image. So if you just draw a straight line, so that will act as a mirror. Right? And this curve or this shape is known as a parabola. Okay, and you already know based on the this sine of a, we have this quadratic equation, right? If a is greater than 0, so this will be in this form, U-shaped. If it is less than 0, it is an inverted U, right? And we also discussed those cases wherein, say, if it is intersecting, it has two roots, right? If it is just touching a point, it has two roots, but the roots are identical, right?
Yes.
So the roots, so when it is in this form, we say that the roots are real because you can represent the roots in the number line, and distinct.
Yes.
When it is just touching this point, you can say the roots are real and equal, right? However, when it is not touching, then you can say the roots are imaginary. Okay, because you cannot, so there is no number line that can represent this root, right? Because it is not touching the x-axis, right?
Yes.
So that is why the roots are not real, they are imaginary. Okay. Any doubt? So you can get questions like find the number of roots that this polynomial has. So see, first of all, once you see a graph, try to understand what it is trying to say. First of all, it is an inverted parabola. So if you, or say this is non-linear, right? It has two roots, right? So ax square, because two roots, so degree is 2. right? So this is of this form, and it is an inverted parabola. So you may be given questions like, so if you have this graph, right, so then which of the following is true? So a is less than 0, a is greater than 0, a is equal to 0, or all of the above or none of the above, right? So you can say that this is true, right? Then you may be given question like b is greater than 0, b is less than 0, b is equal to 0, or something else.
Sir, how do we find that B is positive?
You know the roots, right?
Yes.
Roots are positive.
Yes, so we do that minus B upon C.
Yeah. So see, alpha plus beta is minus b upon a, right? So see, a is less than 0, and this is greater than 0, right? So you can just plug in any value. So see, you know this is greater than 0, so say let this be 5. Okay, I'm taking any number that is greater than 0. So this is 5 equals to minus b. This is less than 0, right? So let this be minus 1. Okay, so minus b is equals to minus 5. So what is the value of b? 5, which means b is greater than 0. Or if you have to show this, so see, alpha plus beta is greater than 0, right? So see, b is equals to, so b will be equal to a times alpha plus beta. This is multiplied by minus, right? Is this correct?
Yes.
So you know a is less than 0, right? So minus a is greater than 0, right? And you already know alpha plus beta is greater than 0, because one root is greater than 0, so the other must be greater than 0. Okay, I mean from the graph itself you can see, if this is greater than 0, this is to the right hand side, so this is also greater than 0, right? So this is also greater than 0, so this becomes sum of product of two positive integers, right? So therefore b must be greater than 0. Okay, what about c?
We can do the product of roots.
Yeah, so alpha beta is c upon a, right? So c is a alpha beta.
So A is negative.
Yeah,
So product should also be negative.
yeah, a is negative, alpha beta, so both of alpha and beta is positive, right? Which means c is less than 0. Okay, now can you tell me how many roots this has? 2 roots, right? So this is of the form ax square plus bx.
Sir,
Yeah,
I was recording the lecture, but it stopped at it.
okay, no problem. Currently my recording is working fine.
Okay.
So you can write it in the form ax square plus bx plus c equals to 0, right?
Yes.
Okay, next, can you tell me the sign of a, b and c?
So A is positive
Yeah,
and B should be negative
why is b negative?
because alpha plus beta is minus B upon A and alpha and beta both are positive.
Okay, so see, how is this positive? This is the origin, right? So this is to the left of origin. So one is negative, the other is positive. Okay, is this clear? One is negative. Both are not positive. Okay. Here, see, this one was to the right of origin. This one was again to the right of origin. So both is, both are positive. Here one is to the left, the other is to the right.
So minus b upon a is negative. So minus b should be negative. So b is positive.
So again, b is minus a times alpha plus beta, right? B is minus a times alpha plus beta. So a is positive, alpha plus beta is negative. So this becomes positive.
Yes.
Yeah. What about C?
C should be negative.
Yeah. Because alpha beta is negative and a is positive.
Yes.
Okay. Any doubt?
Yes.
Okay, so this is easy. To count the root, it is very easy. But to tell the sign, you have to do some interpretation. Okay. Here you can see the graph is cutting or touching at one point, right? So this case, the roots are real and distinct, right? Distinct means different. They are real because they can be represented on the number line, the roots, right? Distinct because they are different. Here the roots are real and equal. Real because again you can represent, because it is exactly touching the number line, so you can represent it on the number line. Equal because it is touching at only one point.
Yeah.
Okay. Now here, a is less than 0.
Yes.
Right. What is the sign of B and C? A negative.
So like one product is one root is 0.
No. So roots are real and equal. So see, the question, the solution looks like this: x square equals to 0.
Okay. So
Okay,
the
or
root.
say x minus 2 whole square equals to 0.
Yes. So both the roots are positive.
Yeah. So root is the same. So if you write the root, it is x equals to 2 comma 2.
Yes.
Okay, so they are exactly the same.
Yeah.
So alpha is positive, so beta is also positive,
Yes.
right? So alpha plus beta is minus b upon a, right?
Yeah. So B should be negative.
But a is also negative, right?
Yeah. So B is positive.
Yeah. Okay, you have to remember these things. So you have to take the sign of a as well. So that is why I'm writing a first, because everything depends on a.
Yes.
Okay, if a is positive, then there is no issue. What about c?
It is It is negative.
Yeah. Here a will be greater than 0, right? Roots are positive, so b is less than 0 and c is greater than 0, right?
Yeah.
Because alpha plus beta is positive, alpha plus beta is minus b upon a. So if a is positive, you don't have to worry about a, right? Alpha plus beta is positive, which means minus b is positive, so b is negative. Okay.
Okay.
Then finally you have this case where it is not touching the x-axis at all. So since you cannot represent this root, but it is a quadratic equation, right? All quadratic equation will have two roots, right? But you can see the roots are not touching the number line. This is the number line for the roots.
So they are imaginary.
Yeah, so that is why you see the roots are imaginary. Equation can be like x square plus 4 is 0. It is not that it does not have any root, it has root, but you cannot represent it in the typical number line. Okay, you have to represent it in a complex plane. So what you do instead is x square equals to minus 4, x equals to root over minus 4. Then you separate it like this, root over minus 1 times root over 4, which becomes 2 root over minus 1, right? So this root over minus 1 is iota, which is an imaginary number. Sorry, this was minus 1. Okay.
So root minus 1 is the only imaginary number which we have, like in the form of I.
Yeah. So you can represent every number using this.
So like are all imaginary numbers negative roots, or there are some more possible?
Can you repeat?
Are all the imaginary numbers negative roots,
Yeah.
or there can be some other cases?
No, they are all. So imaginary numbers are basically. So when you have this, right? So this is the x-axis, this is the y-axis. If you have imaginary number, this changes. So this becomes the real plane, this becomes the imaginary plane. Or real axis, imaginary axis. So all the imaginary numbers you can write in the form of, say, I, or say 3. So for example, 3i, root 3i, 7i. So these are all imaginary numbers. Other than this, so if you see I, it means imaginary. Other than this, you won't have any imaginary number. Okay. Can you tell me what is the value of I square?
Minus 1.
Yeah, I square is minus 1. What is the value of I cube?
Root over minus 1.
Yeah, so you can write minus I.
Yeah.
Right, so because it is I square, it is I square times I. This is I cube. Right?
Yeah.
I square is minus 1, so minus I. What is the value of I to the power 4?
Minus
No,
I.
no, it is not I.
So minus I into I.
See, what is the value of minus root 1 to the power 4?
Minus 1 into minus
Yeah, so what is the value of that?
1.
1.
But
Right,
sir, if we look at it like I cube is minus 1 and I is I. So
I
if
cube is minus I.
yeah. So if we multiply I cube into I, so that is minus I into I.
Yeah, so which is minus I square.
Yes.
Right, you know I square is minus 1.
Yeah.
So minus 1 times minus is 1.
Okay.
Okay. Any question?
No, sir.
Then you can have I mean this is a curve, so it has 1, 2, 3 roots, right?
So it is a cubic equation.
Yeah. Okay. So see, cubic equation can be more complicated than quadratic, because cubic equations can have one real root, two imaginary root. All three roots are real, all three roots are imaginary. So there can be multiple combinations for cubic, right?
6 different combinations.
Yeah. Okay. So similar to, so say cubic equations you can write in the form of ax cube plus bx square plus cx plus d equals to 0, right? So this is the cubic equation, right? Okay, let me do it for quadratic first. So quadratic equation ax square plus bx plus c, right? So the roots are alpha and beta. Okay, if the roots are alpha and beta, which means x minus alpha and x minus beta are factors of this, right? So if you just multiply this, x minus alpha and x minus beta, you must get this equation, right?
Yes.
Is this clear?
Yes.
So then you get x square minus alpha x.
So this was an algebraic identity.
Yeah. So you'll get x square minus alpha x minus beta x plus alpha beta equals to ax square plus bx plus c, right? Then you get x square minus, you can take x as common, you'll get alpha plus beta plus alpha beta equals to this. Okay, now what can you do here?
You can take x common in first and second term.
In first and second term. Okay, so if you take x common,
So x minus
yeah,
a
x,
plus
x minus alpha plus beta
yes. Yeah. Then alpha plus alpha.
plus alpha beta.
So we have to prove they are equal, right?
Yeah, so you have to find the value of alpha plus beta.
So only alpha plus beta should remain on the left hand side.
Yeah. So see, if you just compare these two equations,
Yes.
right? If you just compare these two equations, what do you see?
So like a is 1, right?
A is,
1 because ax square and x square. Yeah.
okay, let A be 1.
Yeah. And b is alpha plus beta minus alpha plus beta.
Hmm.
And c is just beta.
Not beta, but alpha beta, because this is the constant term,
Yes.
right? C is alpha beta. But you cannot say directly that x is 1. Right? So, sorry, a is 1. Because it has some value. It will have some value, obviously.
Yes.
Right? So, what you can do here is say x minus alpha, x minus beta. You already know it is a factor.
Yes.
Right? So, there can be a constant term as well. For example, it can be 2x minus alpha, x minus beta, 3x minus alpha, x minus. So, that may have been eliminated earlier when you are calculating the root. Right? See, sometimes in quadratic equation, what you do, 2 times x minus 2, x minus 3 is equals to 0. So, you write x equals to 2 and x equals to 3. Right?
Yes.
But when you write this in the form of equation, so if you go back, so you'll only get x minus 2, x minus 3. You lose this 2.
Sir, can you repeat?
Yeah, so what I am trying to say is, suppose you have an equation, right? So if you solve or factorize this equation, you got a factor like this. So 2 times x minus 2, x minus 3 equals to 0. Okay, so now you got the value of x as x equals to 2 or x equals to 3. So these are the two roots, right? So you know the roots. So say if you are given the root, can you go back to this equation?
Yes.
No, because you don't know this 2, right? You only know these roots. Right, so
Constant rate.
yeah, 2 is a constant, but when you are writing the entire equation, you have to include that as well.
Yes.
Right, so for example, the equation was x square minus 5x plus 6. Right, so you'll get this equation, but the equation was 2x square minus 10x plus 12.
Okay.
Right, so when you factorize this, you'll get 2 times x minus 2, x minus 3. Right, so the roots will be x equals to 2 and x equals to 3. These will be the two roots, but if I give you these roots, you will only get this equation, not this.
So we will get an equation which is a factor of our equation.
Yeah, right, but not the entire equation. So to ensure that you get the entire equation, you need to add a constant term, say k. Is this clear? Okay, so when you add this k, so this k will be added everywhere. So kx square minus kx plus k alpha beta, right?
Yes.
It will be multiplied to all the terms. So the value of a will be k, not 1. Okay? B will be minus alpha plus beta times k. C will be alpha beta k. Right?
Yeah.
So alpha plus beta, the sum of root is minus b upon k. And you know a and k are equal. So you can write minus b upon a.
Yes.
Okay? And alpha beta will be c upon k or c upon
Yes.
a. Okay? Any doubt?
No, sir.
So you have to, in exam you may be given, prove that the sum of root is equal to minus b upon a and the product of root is equal to c upon a. You have to use this approach.
Okay.
Okay. Similarly, ax cube plus bx square plus cx, you will not get this, but you have to remember this. So see, there will be 3 roots because the degree is 3, alpha, beta, gamma,
Yeah.
right? So again, the sum of root will be alpha plus beta plus gamma, right?
Yes.
So this will be minus b upon e. Okay. Then You will not move directly to product because you have to explore all combinations, right? So then you have to take the product of root taken one at a time. So you are taking alpha and beta first, then adding it, then beta plus gamma, then gamma alpha. Okay, this is equal to C upon A, and then finally you will take the product of root. Alpha beta gamma is minus D upon A. So it is the behavior of roots are different in quadratic and cubic equations.
Yes.
Okay, so in quadratic equation, sum of root is minus b upon a, product of root is c upon a, right? Here sum of root is minus b upon a, product of root taking 2 at a time is c upon a, and a product of root is minus d upon a. So you start from here, okay? So minus b upon a, c upon a, minus d upon a. So you alternate the signs. Okay, any question? So this is also a cubic equation. The only thing is, why is this not quadratic?
Because we have three roots.
Yeah, but you don't see those 3 roots, right? This is not linear, that you're sure, right? But why is this not quadratic?
Because we are having three different lines.
You don't have 3, so it is just touching it here at 0.
Yes.
This this is touching at 2 points. This one was touching at 3 points, right? So this has 3 distinct roots. This has all the same roots. This has one root. 2 roots are the same, one is distinct. Okay, but I'm saying that this can also be quadratic, right? How do you identify that this is not a quadratic equation? So see, we discussed that if it was a quadratic equation, for 2 values of x, you will get the same value of y. Right? Quadratic equation. So, for example, it should intersect or it should go like this.
So it must be a parallel.
Yeah.
Okay.
Right? So 2 values of x should fetch you the same value of y. Then only, because you have x square, a term x square.
So like all the quadratic equations are in the form of a parallel.
Yeah. Okay, even if you have x to the power 4, then also for 2 values or even more values of x, you will have multiple values of y. Sorry, only one value of y. Okay, so multiple x values will fetch you one value of y. So it should not go in opposite direction like this. This is only possible when it is cubic or the power is odd. Say linear equation, you will see the line like this, right? If you take x as negative, the value will go in the negative direction, right? But quadratic equation, if it is negative, it will increase in the opposite direction like this, right? If it is positive, it will again increase in the opposite direction, right? Depends on the value of a, but you'll have the same pattern. If it is decreasing, it will decrease for both the cases. If it is increasing, it will increase for both the ends.
Yes.
Okay.
Yeah.
So can you tell me how many zeros each of them have? This one, 1 0, right? Puneet, am I audible?
Option. Yes.
Okay. How many zeros does this have?
2.
2. This one?
3.
3. This one?
1.
1. This one?
1.
How much?
1.
1. Okay, this one?
4.
4. Y you already know, right? Because the graph is intersecting the x-axis. You should not be writing the graph is intersecting at 4 points. You should specify where is it intersecting, the x-axis or the y-axis. Okay, how many zeros are there?
0.
0.
Only 1.
1.
3.
3.
2. 4. 3.
Okay, so does this mean that the degree is 3?
Yes.
No, it is not necessary.
So it's a quadratic equation. Cubic.
No, it is not necessary. So for example, it has only one root, right?
Yes.
Does it mean that the degree is 1?
No.
No, right? If the degree was 1, it would have been a straight line.
Yes.
It means that one root is real, others are imaginary. Okay? So, by looking at the graph, you cannot surely say whether it is. So, at least because you already know, quadratic equations are like parabola. So, you can say if it is a parabola, then it is a quadratic equation. Other than this, you cannot confirm that if the roots are 2 or 3 or 4, then it is definitely, I mean, if it is cutting the x-axis at 2 or 3 or 4 points, then it is a quadratic or cubic, or I mean, it has a degree of 4. Okay? Because some of the roots can be imaginary, you have seen that. Right? If I give you an example of cubic equation, so take this as an example. X cube plus x equals to 0. Okay, so if you solve this, you'll get x square plus 1 equals to 0. Right? So one root is x equals to 0. Right? Then the other roots are x square plus 1 equals to 0, which means x square equals to minus 1. So x is equals to plus minus root over minus 1, or plus minus I. So the roots are 0, I and minus I. Okay? So one root is real, two are imaginary. So if you draw the graph of x cube plus x,
Yes.
it will intersect at only one point. Right?
Yes.
So that is why it is not necessary that if it is intersecting at only one point, then the degree is 1. Okay? Remember this. Then you have relationship between zeros and coefficients. This we have already seen. Right? So this is known as sum of 0, and alpha beta is product of 0.
Yeah.
Right? So minus b. So if you look at this, ax square, this is a quadratic equation. So sum of its zeros. Coefficient of x is b, right? So minus b upon coefficient of x square, which is a. So sometimes you have to write it in terms of coefficient. Okay.
Okay.
So for example, 3x square plus 5x minus 2. Okay. So if you take, so sometimes we asked find the sum and product of the roots. So instead of finding the roots, you can just do alpha plus beta is minus b upon a, right?
Yes.
Right. Instead of writing this minus b upon a, you should write coefficient of x minus of coefficient of x upon coefficient of x square.
Yeah.
Right. So what is minus coefficient of x? Minus 5 upon 3.
Yes.
Okay. So this is minus 5 upon 3. Product of root minus 2 upon 3. Right. So this is constant term upon coefficient of x square. So this constant term is c, coefficient of x square is a. Okay, and this is the proof that we have already done. Ax square plus bx plus c. So you have written in the form of k times x minus alpha. So I've explained why we use this k, right?
Yes.
Okay, so we'll get. I mean, this is the derivation which you may be asked. Okay, questions like this you may be asked. Find the zeros of the quadratic polynomial this and verify the relationship between the zeros and the coefficients. Okay, so first you have to find the zero by factorization.
Yes.
Okay, so when you factorize, you'll get x plus 2, x plus 5. So what are the roots?
1 and 3.
Yeah.
Yes, sir.
Okay. So, I mean, once you have factorized this, you'll get x plus 2 and then x plus 5, right? So what are the roots?
X minus 2 and x minus
No, x plus 2 is a factor.
2. Yeah.
So what will be the root?
So it's the opposite, right?
Root is minus 2. So to find the root, what you need to do? So x plus 2 times
Yes.
x plus 5 is equal to 0. Root means the value of x for which this is equal to 0, right?
Yeah.
So when is the product of two number equal to 0? When either of them can be 0.
So either x either -2 or -5.
Yeah, so x is -2 or -5. So this is known as root, right?
Yeah.
So this is the root. Okay, so you'll get the root. Now you have to verify the relationship between zeros and the coefficients. How do you verify this? So add the roots. So you'll not say like this, you'll say alpha is -2, beta is -5. Okay? Then you'll write sum of roots. So sum of roots is alpha plus beta. Okay? So this is equal to -2 minus 5, -7.
Yes.
Right? So this is equal to, again, minus b upon a, or you can calculate minus b upon a is equals to -7 upon 1, which is -7. Therefore you can say alpha plus beta is minus b upon a. Is this clear?
Yes.
And then you can also prove that alpha beta product of root is 10. -2 times -5 is 10. And c upon a is also 10, which is 10 upon 1. Okay? Another type of question you'll get, find the zeros of the polynomial this and verify the relationship. So you can find the zero, right? What is the zero of this?
Sir,
Yeah.
plus minus root 3.
Yeah. So one will be plus root 3, the other will be minus root 3. Right? So what will be the sum of root?
Yes. Sum of root. So we don't have b there.
Yeah, so if you just calculate from here. So this is alpha, this is beta. So what is alpha plus beta?
Yeah. Root 3 minus root 3, so it should be 0.
0. And here also you can see there is no coefficient of x term. Right? So don't get confused when you don't see b. Okay?
Yes.
And then you have alpha beta. Alpha beta is
C
yeah. So here you already know alpha and beta, so you don't have to go through this route. So you just multiply and cross check, right? Because it is asking to verify the relationship. Okay. So alpha beta is root 3 times minus root 3, which is minus 3. Here also you can see minus 3. Constant term is minus 3. And coefficient of x square is 1. Okay, any doubt?
Yes.
Another type of question, find a quadratic polynomial, the sum and product of whose zeros. So the sum and product of whose zeros are -3 and 2 respectively. So see, sum is given, so alpha plus beta is -3, right? And alpha beta is 2. So when the roots are given, or when the sum and product of roots are given, so you can write the equation in the form x square minus alpha plus beta x plus alpha beta. Okay. Why we are not writing k here? If there will be some k, then this will be in term of fraction,
Yeah.
right?
Because it is the same.
Yeah.
Yes.
Okay. So since it is a whole number, then that means this must be 1, right? So a must be 1. Okay. Is this clear? So see, this is similar to what you do in factorization, right? So you break this into two parts such that the product is equal to this. Right, so you try to find the factors, or split it into two parts such that when you multiply this, so or the two parts must be a factor of this term, the constant term, multiplied by this. Right? So if you are given the root and you need to find the equation, you need to remember this form. Okay? Any doubt?
Yes.
Okay. So then this question says verify that this, we will not be asked to find zeros of polynomial, cubic polynomials. When you are asked, so I think you have already done those questions, so you have to check whether 0 is a root, 1 is a root, 2 is a root. Usually it will be within this range, -3 to 3, the first root. Right, and once,
Part of one.
sorry?
Like mostly -1 and 1.
You are not audible clearly, Puneet.
So -1 or 1 most
Yeah,
of the times.
yeah. Okay, once you have established that root by checking I mean you substitute those values and then check. Then you can say x minus 1 is a factor of this. So you divide this with x minus 1, you end up with a quadratic polynomial, and you already know how to find the factor of quadratic equation.
Yes.
Right, so this is how you find. Now you are already given the three roots. You have to verify that they are roots of this equation, and then you have to verify the relationship between 0 and coefficient.
So we just put the values at
Yeah. So you substitute 3 and then check it if this is 0. Substitute -1 and then check if this is 0, and then substitute this and check this is 0. Right. And how do you verify the relationship? So you take the sum of roots, so alpha plus beta plus gamma. So this will be 3 minus 1 minus 1 upon 3. Right? So if you add that, you'll get, this will be 2, 2 minus 1 upon 3, 6, 5 upon 3. Right? And minus b upon a is also 5 upon 3. So this you will verify. Similarly, you will take the sum of roots taken 2 at a time. Alpha beta plus beta gamma plus alpha gamma. Okay, so multiply this with this, then this with this, and then this with this. And then add all of them. Right, so this must be equal to d upon a, minus 11 upon 3. Right, so this is just, I mean, it will just take time for calculating, nothing else. Right, so this you'll get minus 11 upon 3, which is c upon a. And then alpha beta gamma, if you take the product of root, which is 1, and 1 must be equal to minus d upon a. So minus d, which is minus of minus 3, which is 3 upon 3, which is 1. Right. Your voice is breaking.
Sir, how much of the chapter is left after this?
It is done. Okay, so I think this exercise is the only thing that you need to do, and these are very simple. So you have to find the 0 and then verify the relationship. Right, and this we have already done. You have to find the quadratic polynomial from the sum and product of its roots. So sum of root is this, product of root is this. So if you want, so see, alpha plus beta is 1 upon 4. Alpha beta is minus 1. So the polynomial would be x square minus alpha plus beta x plus alpha beta, right? So x square minus 1 upon 4x minus 1. So this is the polynomial. Right, here you just have to find the 0. Again, this is simple. So this will be x square minus 4x plus 2x minus 8. So you'll find the zeros and then verify alpha plus beta. So you'll find the value of alpha plus beta from the roots that you just got. Right. And then you'll check what is the value of minus b upon a. If they are same, then you have verified it correctly. If they are different, then your root must be wrong. You have to re-verify your root. Okay? Any doubt?
No, sir.
Okay, cubic is very important here, although you don't have a question on cubic. But in R.D. Sharma, you have a lot of questions. Okay. So for chapter 1 and 2, I will share some questions from boards. Okay. So I mean previous year papers. I'll share some questions from the previous year papers so that you can solve. So you get idea on what type of questions are asked. Okay. Okay. I mean continue solving R.D. Sharma of this. If you have any questions, we can discuss. Okay. Otherwise, I'll just take one more class to cover some advanced concepts of this and then close this chapter.
Sir, we can have 2 classes tomorrow.
Okay. Morning, I think around 1. Evening, I can confirm later. Okay. Is 1 p.m. fine for you?
Yes, sir.
Okay. Fine then. Okay then. Bye. Good night.
Bye, sir.